In this video, I'm going to explain what quantization is. I'm also going to explain some basic concepts of quantization, and I'm going to show you a live code demo on how to quantize your large language models using Llama.cpp and Hugging Face libraries. Okay. Without any further delay, let's dive into the main topic. And what is quantization? Let's ask ChatGPT what exactly a quantization is, right? What is quantization when referring to large language model? Okay. So we got the response from ChatGPT, and ChatGPT is saying that quantization is a technique used to reduce the memory footprint and computational requirements, right? So basically, we do quantization to reduce the amount of GPU RAM required and also increase the speed of the inference, right? So let's say to run whatever the large language model, let's say it takes 28 GB of GPU RAM and you only have like around 24 GB in your machine, right? So you can quantize the model to reduce the amount of memory requirements and so that you can easily run the large language model, right? So what exactly happening here is during the quantization, you are taking a base large language model with whatever the precision, and you are converting to a lower precision of the same large language model. So let's say you are quantizing Llama 2 7 billion parameter, which is on B float 16 precision. So to reduce the memory requirements, you can actually convert that to int 8 or also normal float 4 bits. So let us ask ChatGPT something so that you can understand what I mean by reducing the precision of BF float 16 to int 8 or float 32 to float 16 and all those things. Okay, so let's ask ChatGPT something. Convert some numerical value. Okay, 204 in FP32 binary value. Okay, so ChatGPT is giving its response, and it's actually explaining a lot. We're not worried about all this explanation, but we are only want this final answer. And if you see this final answer, this 204 can be represented in binary floating point 32 precision like this. Okay, so basically it has 32 bits of zeros and ones, and you can also actually represent the same 402 in FP16, right? So it's again explaining us how to come up with the binary value, but I'm not interested in that. We are interested in the final value, and if you see the final value, right, it has only 16 bits. So to save the same number, which is 204 in FP32, you need 32 bits of space in your GPU RAM, right? So if you want to save this 204 in FP16, you need only 16 bits of space, and same thing with 8. Okay, you can also actually convert this to 8. You can represent the same 204 in 8 bit. It only takes 8 bits of RAM. So what exactly we are doing is we are taking something which is in the floating point 32 and converting into the floating point 16, or something that we are taking a base model which is of higher precision value and we are converting into the lower precision value. Okay, so that we can actually reduce the memory requirements. Okay, how much memory requirements we are reducing here? If you are converting FP32 to FP16, or the most advanced 16-bit precision is called BF16. B stands for brain floating point 16. So when you're doing this, you are just reducing the memory by half. And if you go to int 8, you are actually reducing memory by another half of this FP16. So that's a considerable amount of memory reduction. Okay, so now we understood what quantization and why we do quantization, right? So but there are two kinds of quantizations, right? And one is PTQ and the other one is QAT. Okay. Here is my whiteboard where I'm going to explain what is difference between PTQ, which refers to post training quantization, versus QAT, which means quantization aware training. So the name itself says, wait, let me write this here, okay? Quantization aware training, okay? So if you see the name itself tells what exactly it is. What it's saying is you have a large language model, which is a pre-trained or fine-tuned large language model, and then you apply a quantization on top of that. So let's say there is a Llama.cpp, which is takes around roughly around 14 GB. Now you can apply quantization, let's say int 8, then it only takes 7 GB. Okay, so you have a large language model which is already trained and you apply quantization technique on it so to reduce the memory requirements. Then there is something called quantization aware training. So this is something where you do the quantization during the training process, and one of the example is QLoRa. So I'm not going to go or explain about quantization aware technique in this video, but we're going to go in detail about PTQ. Okay, so now we know that PTQ is something which you apply on the pre-trained or fine-tuned large language model, right? So what are the different kinds of PTQs we have? One is GPTQ, and the second one, bits and bytes. So bits and bytes, you can actually use it during the training. You can also use this after the training, okay? So there are two things, GPTQ and bits and bytes, and you can also actually quantize using Llama.cpp, okay? So there are three techniques to do. Let's say you have a 70 billion parameter model and 7 billion parameter model, okay? And now you did aggressive quantization and applied 4-bit quantization technique, and you apply the same 4-bit quantization technique here, okay? So the degradation of the quality of the responses is not a lot when the model is bigger, like 70 billion, okay? But when you aggressively quantize the smaller models, the quality of the responses have a significant negative impact, okay? So the quality of the responses here is bad, and here is fair, okay? The quality is fair, here it's bad. So what I'm trying to say is the bigger models, you can do aggressive quantizations, but coming to the smaller models, I would recommend quantize to 8-bit instead of 4-bit, because smaller models 8-bit quality of response is fair, but 4-bit quality of response is bad. Next, let me explain what is uh, GPTQ and how to run GPTQ. So GPTQ is a quantization technique where you apply post-training quantization. PTQ refers to post-training quantization, and you're applying a quantization method on a large language model to convert from either 32 or 16 to maybe 4-bit. Okay, so now because the structure of the large language model, right, whether you're converting from 16 to 4 or 30 to 4 or 16 to 8, you're actually changing something within the large language model, right? So to run this quantized version, you need a special packages or special libraries to run, and some of the special libraries which you can use to run this GPTQ quantized models are Xllama, Aut- AutoGptq and GPTQ for Llama. Okay, you can use either of these libraries to run a quantized version using GPTQ algorithm, right? Okay, so I'm not gonna cover XLlama or GPTQ for Llama, but I'm gonna cover AutoGptq because this library is integrated with the Hugging Face, and to run model using Hugging Face libraries, I feel, in my opinion, is the most easiest way and most effective way. Okay, because AutoGptq is already integrated with the Hugging Face library. We, if you have a code which you are running, or which you are running using Hugging Face transformer libraries, then all you need to do is just install the AutoGptq library, and also you need to install Optimum library provided by the Hugging Face, and then you can run your code as it is without any issues. So let me show you something before going to the code. Okay, so this one, if you see here, this is a GPTQ version of Vicuna 30 billion parameter large language model, and this model is uploaded by the blog. I'm pretty much sure everybody knows about this dude. He's very active in this community. So if you see here, he will give some instructions on how to run uh, this model, right? And one of those instructions is uh, he asks us to install something, right? So if you see here, he's asking us to install transformers because you are using Hugging Face transformers, and you need to use Optimum, which is also a part of Hugging Face, and then you need to install AutoGptq. Okay, so once you install these three things, then you can run a large language model which is quantized using GPTQ algorithm. All right, so I logged into my server. This is a VS Code. I use VS Code to run all the Jupyter Notebook and large language models in my home server. Um, but yeah, so I have compiled a few code snippets here, which actually helps you to understand how to run a quantized version of the large language models, and also I'm going to show you how to quantize the actual large language models. So let us start with AutoGPTQ version. So I have downloaded this Vicuna 30B GPTQ version, which is 4-bit. Let me show you my server configuration. So I have two 12 GB GPU memories, as you can see, two 12 GB GPU memories. So in total I have 24 GB, and there is no way I can actually run Vicuna 30 GB without quantization, right? So what I did is I have downloaded this quantized version, and using the Hugging Face transformer classes, I was able to run without any issue, and the same exact instructions you can find in the blog uh, page here. These are the same exact um, code snippet. Now, so let me load it, okay? And before it loads, I can explain few things here. So the model base path. So I have downloaded this large language model here, okay, in my server, right? Okay, so there are two things you need to see here. Is one, we need to load the model itself, and then we need to create a tokenizer. Then to load the model, so this is the class and this is the method. All we are saying is load a method, and the actual model is present in this path, and the device map auto says that just try to fit the model according to the GPUs. Okay, if I have two GPUs, it will distribute the model in two GPUs. If I have only one GPU, it will fit the model in one GPU. And if you are using accelerator package, then it will also fit the model in the GPU, then it will fit the model in the RAM. CPU RAM, and then if you still have, if you still want, if you still don't have enough RAM, it will loads the model in SSD or NVMe, whichever you have. Okay, so what this saying is the first parameter is saying where exactly the model is. The second parameter is you are telling the package that just go ahead and distribute the large language model based on my hardware. And then there is something called trust remote code false. So what is this is, so now I'm keeping here as false because the Hugging Face already has the information or already has the code for the Vicuna transformer architecture. But let's say this is something newly released application, okay, sorry, newly released large language model, and the Hugging Face do not have any information about their transformer architecture, right? So then you can pass through as here. So what exactly it does is when you pass through, it actually tries to execute the code which is in the GitHub or wherever the code is present. So that is for these three things. And if you are actually pulling the code from the GitHub or from the Hugging Face, this revision equal to main, what it does is it actually pulls the large language model from the main branch. Okay, so that's all for these parameters. And now here for the auto tokenizer, what we are doing is we are tokenizing or we are creating a tokenizer. Okay, and we are creating a tokenizer for based on the model. And you can put this true or false, but this is a whole different discussion. But yes, so you have to load a model, you have to load a tokenizer, then you have to create a pipeline, right? So this is how you create a pipeline, and in the pipeline you can see that I'm passing the tokenizer, I'm passing how many new tokens I'm expecting or what is the max new tokens. So if in here the response is limited to 512 tokens, then there are some other hyperparameters. I'm not explaining what hyperparameters are in this video. Then after you create a pipeline, then you can generate the response. So my prompt is tell me a toddler rhyme, but also add some humor to it. So now let me run this. See, I have 24 GB GPU RAM. There is no way I could have run this 30 GB without quantization, right? So now what I did is I downloaded the quantized version, which is a 4-bit version, and I'm running it using the Hugging Face transformers, AutoGptq, and Optimum. Okay, so now you see here I got a response. But whatever the response is, I asked to tell a toddler rhyme, and it actually gave us a toddler rhyme. So it's working good, right? It's working good. So what else I'm doing here, right? So if you see here, prompt generator, this is my own function, and I can show you the prompt generator. So in this function, what I did is I have used this prompt template. And where did I get this prompt template from? From the same place where I actually downloaded this large language model. Here somewhere I see this is the prompt template, right? So all I need to do is copy this prompt template, and I have to replace this prompt with my prompt. So that's what I'm doing in this function. This is a basic Python function. Okay, so what's happening here is this pipe object is generating some response, right? And that response is coming from the large language model. Okay, so let us try to print this pipe and see why I have to add this, sorry, why I have to add 0 and generated text. Let us analyze what's in the response. All right, so let's see. So this response comes in a specific format, right? So I need to pull the data from that specific format. I want to show you what specific format is, okay? And the format differs when you use Llama.cpp and when compared with the Hugging Face transformers. Okay, if you see here, right, without this, without 0 and generated text, this is the response I received. Let me copy this and put it in a new text file. Okay, so what exactly happening here is the Hugging Face transform responded with this string, and this string is in whenever you see a brackets, which means it's a list. So you need to pull this information out first, right? You need to pull this information out. So when you pull this information, how do you pull this information? Because this is the 0th element, that's why I am giving 0 here. Okay, 0. So when I say 0, I am pulling this information out, this JSON object. Okay, so once I retrieve this JSON object, I'm only interested in this part, not on this generated text part. So what I did is I pulled the 0th element and then I pulled the generated text. Okay, whatever the text or whatever the value under this generated text key, I'm pulling that and I'm printing as a response. So that is what's happening here. So let me summarize what I did. All I did is I have installed Optimum, I have installed AutoGptq, and I have installed transformers. And then I have loaded the model. I have created a tokenizer, created a pipeline object, and then I executed the prompt. Then based on the response from the pipeline object, I have pulled the 0th element, and then within that element, I have pulled the value of generated text and printing here. So that's what I did. Okay. Then how do we actually quantize? That's this one so far so good. I have actually downloaded the quantized version already, right? But what if you have something where it's not in the Hugging Face and you want to quantize by yourself, right? Yes, it's actually easier, but unfortunately I cannot show you guys in my local. The reason is I only have 24 GB, and quantizing using GPTQ is very resource intensive. But what I can show you is I can show you some code which actually tries to run but gives an out of memory. Okay, so here is the code which I use to quantize the GPTQ. So Hugging Face provides this GPTQ config class, and using this GPTQ config class, you can actually quantize the model. Okay, so you are creating the tokenizer just like before. Now all you're doing is one extra step is you are creating a GPTQ config. Okay, and you pass what are the bits you want to do. You want to do 5, you want to do 4, you want to do 8, do it. Then you need to pass a data set. One difference between Bits and Bytes and AutoGptq is that you need to pass a data set here. And then you are passing the tokenizer as well. Okay, one thing to remember is if you see some examples in the internet, you see that they are actually passing some C4 or wiki text, and because they are using a wiki text dataset which is in the Hugging Face to do the quantization, right? But let's say you have your own dataset. Okay, let's say you have your own dataset and you want to quantize using your own dataset, and you might ask, why do you have your own dataset? Maybe you have fine-tuned your application, right? Maybe you have fine-tuned an application and you want to quantize based on the dataset which you used to fine-tune your large language model, right? So in this case, what you need to do is you need to create a data set which is like this. Okay, let me show you how it should be. It should be an array. So custom data set should be list of strings. List of this is data 1, data 2, and data 3. Okay, data 1, data, and and to get the best results, it is recommended to have at least 128 samples. Okay, at least to have 128 samples in your custom data set. So now let me show you something, right? So I have fine-tuned a lot of large language models, and one of the fine-tuned data set is this one, which is in the JSON format. So this is a Python script or Python code, which what it does is it reads the file, JSON file, and it appends to the array. Okay, this text values array, and there's only 68 of them, but the recommended one is 128. But what you can do is you can create something like this, where let's say your data set is in a plain text. Okay, so you read through the plain text and append one after other in an array. Make sure you have at least 128 strings, and then pass that to the data set here. So now you have created an array of strings, and you can pass that array of strings in the data set, and you can run it and it will quantize your model. So that's how you can actually quantize or you can create your own GPTQ version of your own models. Okay, so now let me show you the quantization technique for Llama.cpp. For this, all you need to do is install the Llama.cpp library. So let me show you the instructions on how to install Llama.cpp library. So there is a GitHub where all this Llama.cpp related information is present, and even the code and all the scripts you can see here, right? So go to this GitHub, and then you can see, if you scroll down, you will have the instructions, and one of the basic thing you need to do is you just have to clone the repo and then go into the folder where you have cloned the repo, and then just build it. If you're Linux, just give a command called make. If it's a Windows, there are some instructions, and if it's Mac, there are another set of instructions. So after you install the Llama.cpp, how do you use it to quantize? For this, I'm gonna show you how to quantize a Mistral 7B. So I have downloaded this Mistral 7B in my local, this one. So if we go to this folder, right? If I go to this folder, I can show you, right? Yeah, if I go to this folder, there are some files here. Okay, if you see, you can see these files. Okay, so when you quantize it, it will create a 16-bit quantized version of this model, Mistral 7B. Okay, let me run this and I'll show you. And to quantize, all you need to do is just run a Python script, and that is called convert.py, and you are passing where exactly the model is, and you are also passing what type of output you want. Here I'm just saying F16. Let me run this. So it's quantizing. It should take less than a minute or two. If it's a bigger one, it takes more than that, but because it's just a 7 billion parameter model, it shouldn't take that long. So if you see here, it's already done, and in the end it creates a file with an extension .gguf. So let me show you something. In the Hugging Face, if you see, the blog guy, he also uploads gguf version of all the large language models. And how does he do it? He does like this. He just runs this command, and you will see the gguf model. But one thing to understand, this gguf model, whatever you're seeing here, is F16. Now let's say you want to convert this, or you want to quantize this into 5-bit. Okay, then you need to do or run another script called quantize. And where am I getting these scripts from, or this quantize or convert.py? In the same in the same folder where I actually cloned the Llama.cpp repository. Okay, if you see here, this is where I cloned, and inside this Llama.cpp there is this convert.py Python code, and the same thing. Inside the Llama.cpp, there is something called quantize one. So you are executing this quantize one, and you are passing the where this F16 gguf is, and you are also passing where should the quantized version should be saved. Okay, so you are just passing input and output, and you are just giving a name. Okay, this is the name I chose to give. You can give whatever the name for your quantized model. So now let me run. But before that, if you see here, right? If you see here, it has created f16.gguf. Before it was not there, but then it created it. So now let us run this and try to quantize a little bit more. And I need to give you one more information here. So you're running the script, you're passing 3 arguments. One is the input where the model is, One is the output, where to save the model and the name of the model, and also what is the method of quantization. So here I'm applying Q5KS. So where do you exactly get this information from? In the same Llama.cpp repository, okay, there is an information of this, all the methods, okay, F16, Q2K, Q3KS, Q3KM, Q5, Q6, right? You can use any of these. So I'm going with the Q5KS. Okay, so let me run this quantization script. Let's see what's going to happen. So once the quantization script is completed, you will see a 5-bit quantized model with this name in this path. Okay, because the second argument is the path where the quantized LLM should be saved. So once it is done, you will see that. Okay, let's check that here. It's done. It took like 22.5 seconds, and let's see, and it's here. So this is how you quantize a large language model using Llama.cpp. Okay, how do we run the Llama.cpp? The best way to run, as far as I know, it's only my opinion. You can actually run it in any other way if you know of. But what I can show you is running Llama.cpp quantized model using LangChain is much easier. Okay, so I have installed LangChain, and this Llama CPP package, it is provided by the LangChain. So you just import this one, and then you can run. You initialize the LLM in this way. I'm going to explain all the parameters which I'm passing, and then you will run the prompt. So let me show you how to run this. All right, so let me run this. Okay, so it's loading. If you see here, right, it's loading. And what I'm doing here is, um, if you see here, what I'm doing here, I'm specifying all 26 GPU layers should be on the GPU. I mean, 26 layers should be loaded on the GPU, and the rest can be on the CPU. I'm also passing what is the context length, and all these are hyperparameters, and I'm splitting the tensors. All right, it's still loading. And the reason it's loading this long is because I'm actually loading a 70 billion parameter model in my local. Okay, so I have 24 GB of GPU RAM, and my RAM is CPU RAM is 64 GB. So using the Llama CPP, the main benefit of using Llama CPP is you can actually load your quantized model on GPU, and also you can load on CPU, and also if you want to load on a hybrid basis, like some on GPU and some on CPU, you can still do that. So I'm showing the hybrid mode, where I'm saying that load 26 layers on the GPU and the rest has to be on the CPU, right? So now it's loaded. Okay, the application, sorry, the LLM has been loaded. Let me show you how my GPU RAM is consumed. If you see here, me increase this a bit so that it's easier for you to see. So 8 GB on the GPU one and another 8 GB on the GPU two. So 16 GB is occupied by these 26 layers, and the rest is loaded on the CPU. So how do I know it's 26? I don't know. I just played with it. Okay, I just played with it until I got a acceptable number. So let me show you something. So I'm unloading everything again. If you see, I unloaded everything. I mean, the large language model is unloaded from the GPU. So now instead of 26, let's say 22. I started off with 22. I just pick a random number, 22. I did a run, and I checked how much GPU RAM it is taking for this 22 layers. And then I increased slowly up until 26. 26 is what I like. So I'm just gonna stick with 26, okay? So if I do 22, So this is how much is occupied, right? 7 and 7. So in I'm gonna keep it 26. Okay, I'm gonna keep it 26. Let me restart this again. If you see it's unloaded, now I'm gonna load again with 26. Right. So I'm loading 26 of them, 26 of the LLM layers, large language model layers onto my GPU, and it is distributed. Okay. It's a multi GPU setup. All right. So now without Llama.cpp, there is no way I could have actually ran this 70 GB Llama model on my local. Okay, there is no way because I only have 22 GB. So now you might say, oh, why not you just run with GPTQ version of the quantized model? If I do that, I need to put all the LLM, or I have to load the 100% of large language model onto the GPU, and I don't have that much GPU, right? So you might be in my position where you want to run 70 GB, but you don't have a lot of GPU, but you still want to run it. So what you can do is download the 70 GB version, convert it into gguf format the way I showed you, and then play with it. Play with how many layers you wanna load onto the GPU, right? And the rest is gonna go to the CPU. So now this large language model is loaded on the GPU. Now let me run this prompt, okay? It takes time because now we are utilizing CPU and GPU, and CPU inference is really slow when compared to GPU inference, right? So it takes time. Okay, so based on my exercise, I see that it takes around 3 to 4 minutes just to get a response. Okay, all right, so while it's running, let us go to a different topic called let us go to a different topic called bits and bytes. So there is another way we can actually quantize our application, and that is using bits and bytes package. Finally, we got a response from running this 70 GB Llama model using the Llama.cpp, and it took 5 minutes 44 seconds. So I asked the Llama.cpp just like I asked uh, in the other demo. I asked the same exact thing. Tell me a toddler rhyme, but also add some humor to it. So this is what it responded with. Okay, let's see what it actually did a good job, right? It's a 70 GB model, even though it's quantized like with the 5 bit, 5 bit. It did a good job. Okay. Right. So this is one advantage of using Llama.cpp, where you can actually run a huge model in your local. You can actually offload some to GPU and offload some to CPU. Okay. So next, we're gonna look into bits and bytes. So bits and bytes is another package with which you can actually quantize your model in 8-bit or 4-bit. Okay, so we also use bits and byte during QLoRa fine tuning, but that's a whole different topic. But Hugging Face library has integrated bits and bytes, so it's much easier to use bits and bytes using the Hugging Face libraries. So let me show you a demo on how to load using bits and bytes. Okay, so to load your large language model using a bits and bytes, all you need to do is use this line. Just tell the Hugging Face classes whether to load in 8-bit or whether to load in 4-bit. Okay, so for this demo, I'm using 13 billion parameter, Llama to 13 billion parameter, and I'm trying to load in 8-bit. Okay, so let's see. All right, I see some error. Let's see what it is. Requires accelerator. Okay, so this kernel do not have the accelerator installed, but I have the other one which has the accelerator installed. So let's see. All right, so now it's running. um, so what's happening here is you are telling the Hugging Face library that load this model which is saved in this path, okay, which is saved in this path. And we are saying device map auto, which means either load on one GPU. If you have two GPU configuration, it loads or distributes in both the GPUs. And if you use accelerator, it also loads in the CPU RAM, okay. But for this, loading 8 bit for 13 billion parameter model, 24 GB is more than enough. So let's see how much it occupies or how much it consumes. Let's see my GPU. So I loaded in 8 bit, then this is how much it consumed, right? So let's say you don't have 24 GB, right? So you might only want to load in 4 bit. You can definitely do that. But all you need to do is just tell Hugging Face class that load in 4 bit and now run it. So let it load and we will see how much GPU RAM is needed to load in 4 bit. In 8 bit combined is like around what, 8 plus 6911, let's say 7. 8 plus 7 is 15 GB, right? So this one takes 15 GB. Now let's see how much it takes in 4 bit. All right, loading is done. It took 27 seconds. If you see here, now it only took 9 GB. So all you need to do is pass this parameter and it does everything it needs to do, right? So then just as usual, you need to create a tokenizer and just you need to create a pipeline object just like before, and you can just run and see the response. So let us run. And it's the same exact prompt which I've been using since the start of this video. All right, we got a response. It took 44 seconds compared to around 6 minutes for 70 billion parameter model. And the response is, I'm not sure what exactly this response means. It says, once upon a time there was a two mice living in a hole. I don't know. It's 13 billion parameter because I'm loading it in 4 bit. Probably that's the reason it is giving some response which doesn't make any sense. And it also gave some code. All right, so I did not ask this. I don't know where this information is coming from, but yeah, so that's it guys. So in this video I explained what quantization is, what are the two different kinds of quantization. I showed you how to quantize using Llama.cpp. I explained you how can you quantize using GPTQ, and also how to pass the custom data set. I also showed you how to run the quantized model using Llama.cpp and also using the Hugging Face transformers. And we also did a quantization with Bits and Bytes using Hugging Face transformers. Hope you like it. Thanks.